For centuries, we've looked to the stars for signs of alien life, mostly believing that our own planet's mysteries were figured out. We knew the deep ocean was cold and crushing, but the prevailing view was that it was also a biological desert. The idea was simple: without the sun's rays, life as we knew it just couldn't get a foothold. For most of human history, this vision of a mostly lifeless abyss dominated our understanding. We were wrong. What we have now found, thriving in the permanent, crushing dark, right next to some of the most violent forces on our planet, doesn't just challenge what we know about the ocean. It changes everything we thought we knew about life itself. The old world, a barren wasteland. To really get the magnitude of this, you have to appreciate the old way of thinking. Life on Earth is powered by the sun. Through photosynthesis, plants and algae turn sunlight into energy, and that forms the base of nearly every food chain. No light, no food. And in the deep ocean, below 1,000 meters or so, there's no light. It is a realm of eternal midnight. Then there's the pressure. At these depths, the weight of the water above is immense, about 100 times the atmospheric pressure you feel at sea level. The temperature is just a little bit above freezing. For decades, scientists believed any life down here would be sparse, just a few scavengers surviving on the meager scraps of organic matter, called marine snow, that drifted down from the sunny world above. It was seen as a world of slow, solitary survivors in a vast, empty desert. That was the accepted truth. The deep sea was a place of endings, not beginnings. But then, in 1977, an expedition near the Galápagos Islands stumbled upon something that just didn't fit. They weren't even looking for life, they were studying underwater volcanoes. But what their deep-sea submersible, Alvin, lit up in its headlights was not a barren landscape. It was an oasis, teeming with giant, blood-red worms, ghostly white crabs, and fields of oversized clams. It was a dense, thriving ecosystem, flourishing in total darkness. The scientific community was floored. The discovery asked a question that would turn biology on its head: how is this even possible? The revelation: a world without sun. The answer wasn't in biology, but geology. These oases of life were clustered around things called hydrothermal vents. These are bizarre, chimney-like structures on the seafloor that often form where tectonic plates are moving apart, but also show up in other geologically active spots like subduction zones. Here, seawater seeps down into cracks in the Earth's crust, gets superheated by magma, and then erupts back into the ocean as a mineral-rich soup. Some of this fluid can reach temperatures over 350 degrees Celsius, which is hotter than the melting point of lead, yet it doesn't boil because of the insane pressure. This toxic, scorching fluid should be a death sentence. But instead, it was the source of all the life they were seeing. These organisms had evolved to do something revolutionary. They didn't need the sun. They were powered by the Earth itself. The process is called chemosynthesis. Instead of using sunlight, specialized bacteria and other microbes harness the chemical energy from compounds like hydrogen sulfide, which smells like rotten eggs and is toxic to most of us, spewing from the vents. They use this raw chemical energy to create organic matter, becoming the foundation of a completely new food web. In essence, these bacteria are the plants of the deep sea. They feed the crabs, the shrimp, and the snails. It was a monumental realization: life had found a way to create energy completely independent of the sun. Now, it's not totally decoupled. Many of the larger animals at these vents still rely on oxygen that ultimately comes from photosynthesis at the surface, but the energy at the very base of their food web is entirely terrestrial. The bizarre inhabitants and the life this process supports is stranger than science fiction. Take the giant tube worms. These things can grow to be over 6 feet long, anchored to the volcanic rock. They have no mouth, no eyes, and no stomach. They don't eat. Instead, their bright red plumes filter chemicals from the vent water, which they deliver to huge colonies of chemosynthetic bacteria living inside them. The bacteria produce sugar, feeding the worm from the inside out in a perfect symbiotic relationship. The worm provides the home and raw materials, the bacteria provide the food. Then you've got the Yeti crabs, named for their hairy arms. These crabs wave their claws in the mineral-rich water, but it's not a dance. They're cultivating gardens of chemosynthetic bacteria on their own limbs. When they get hungry, they just comb the bacteria from their hairs into their mouths. They are, literally, deep-sea farmers. These aren't just isolated curiosities. All around the world, wherever these hydrothermal vents are found, entire ecosystems flourish. Recent expeditions keep finding not just new species, but new groups of animals that push the boundaries of how we define life. In fact, very recent discoveries have revealed that this world is even more complex than we imagined. Scientists have found evidence of an entirely new ecosystem existing underneath the seafloor itself, in the volcanic cavities and tunnels created by lava flows, home to bacteria, worms, and snails. This suggests that life may be traveling through cracks in the Earth's crust to colonize new areas, a hidden biosphere beneath the ocean floor. Rewriting the rules of life. So what does this all mean? Why does it change everything? Because it fundamentally expands the known rules for life. It proves that sunlight isn't a non-negotiable. It shows that life can thrive in crushing pressures, total darkness, and next to temperatures that can melt lead. If life can exist here, where else could it exist? This has led to a fascinating and powerful new look at our own origins. For a long time, a popular idea, famously sketched out by Charles Darwin in a letter, was that life began in a warm little pond on the surface, sparked by sunlight and lightning. While that's still a contender, some scientists now believe that the very first life on Earth might not have begun in the sunlit shallows at all, but in the crushing dark of the deep ocean. Think about it. The early Earth was a violent place, bombarded by asteroids and scorched by intense ultraviolet radiation. The deep ocean would have offered a safe haven. Hydrothermal vents provide a constant, reliable source of chemical energy, a rich soup of minerals, and countless tiny rock pores that could have acted as natural test tubes, concentrating chemicals and kickstarting the reactions that led from non-living chemistry to the first living cells. This deep-sea cradle theory is a major hypothesis suggesting that vents could have been the planet's first engine of life. The implications ripple out far beyond Earth. If life can begin without sunlight, powered by geothermal energy, then the search for extraterrestrial life just got a lot more interesting. We can look at the icy moons in our own solar system, like Jupiter's moon Europa and Saturn's moon Enceladus. Beneath their frozen shells, scientists have strong evidence of vast, liquid water oceans. And because of the tidal forces from their giant parent planets, their cores are likely geologically active. Data from probes like Cassini and recent simulations suggest that these alien oceans could very well have active hydrothermal vents on their seafloors, potentially providing the same ingredients that support life in our own deep ocean: water, chemical energy, and minerals. Suddenly, those dark, cold moons at the edge of our solar system look like some of the most promising places to search for life. From a supposedly desolate wasteland to a dynamic world that may hold the secrets to our own origins and the key to finding life beyond Earth, our understanding of the deep ocean has been completely transformed. Every new expedition brings back astonishing discoveries. In the last few years alone, missions from the Ocean Census Project have identified over 1,000 previously unknown species, from ghost sharks to bizarre corals, revealing just how much is left to find. It's often said we have mapped the surface of Mars with more detail than our own ocean floor, and in terms of high-resolution mapping, that's largely true, highlighting just how little we really know. This hidden world is a profound reminder that our planet is still full of fundamental mysteries. These deep-sea ecosystems, powered by the Earth's inner fire, aren't just a biological curiosity, they are a new chapter in the story of life. They force us to reconsider where we came from, and where else life might be hiding. The deep ocean isn't a wasteland. It's a crucible of creation, holding secrets we are only just beginning to uncover. What do you think is the biggest secret the deep ocean is still hiding? Let us know your thoughts in the comments below. And if you want to keep exploring the hidden corners of our world and the frontiers of science, make sure to subscribe. You won't want to miss where we're going next.